With our latest RapidMiner 9.9 release, we are now adding the ability for you to actually create custom operators using Python code. For example, this isolation forest or the light GPM operator that you see are actually built completely using Python. So to use them, I can simply drag it in the workflow, and you'll notice just like any other RapidMiner operator, it has nice set of parameters the users can make selections from. It has good default values set by the developer. And obviously there's the description and the help provided around each of those parameters. So now it makes it possible for non-Python developers to actually leverage Python-based packages and libraries in a simple drag and drop environment like RapidMiner. So let's see how we'll use this to actually build a model. So since I have the light GPM operator here, I'm going to bring in the reference data set over here. And to build a model, I'm just going to connect the data to the light GPM operator. Once the model is built, I want to apply it on this new data set. So I'm going to go ahead and bring those in. And then I will be using the classic RapidMiner apply operator to connect the model and the new data set that I want to get the predictions on. And the output of that would be my labeled data set and the predictions. And to run it, it is as simple as running any other RapidMiner workflow. But behind the scenes now, this is using the light GPM algorithm from Scikit and applying the model like with any other RapidMiner. So that's the model details. And these are the output. You get to see the predictions and the confidence of the predictions. So pretty much any RapidMiner operator is now compatible with Python-based operators when it comes to machine learning. And eventually we can also talk about the data transformers. What we mean by that is obviously you can use simple operator chain like I just showed you here, but if you want to combine, let's say that with a cross validation. So in this case, I'm cross validating the light GPM model. The RapidMiner operator cross validation can understand that model and eventually apply it also. Similarly, if I want to optimize the parameters, I can start using the RapidMiner optimize grid operator. Instead of that, I have the cross validation of a light GPM. And to optimize which parameters, you simply go to the settings and you'll notice in the light GPM, I can pick up which parameter to optimize and what are the ranges, what type of scale I want to use, and so on. So essentially, because now the models are compatible, you start getting the benefit of using the RapidMiner drag and drop capabilities for feature tuning, feature selection, parameter tuning, and so on. This is much better than the classic way of doing Python-based learners in RapidMiner, because previously to understand a Python model, you had to write another Python script. And to optimize parameters, you had to use either macros or you'd have to code the Python script to take care of the optimization pieces. So it became almost a full Python-based code that the new users may not be comfortable with. But with this ability now, we are allowing the Python users to provide their code, provide their solutions in a simple drag and drop operator that anybody can leverage, whether they know Python or not. Now the functionality is also extended to other things. So for example, we also are providing a new Python-based transformer that allows us to create read operators, write operators, or data transformation operators, which can be then again shared with the rest of the community. So let's see how we actually build one of these operators. So I'm going to start on a clean slate. And I'm going to drop this to make it quick here. Essentially, to build an operator, you bring in the Python learner object and you provide a couple of things. You provide the Python script and the settings. So let's look at what the light GPM code looks like. So the two things here are, because this is a machine learning operator, I have to provide the code that will be used during the training phase of the model. And I have to provide the application phase that will be used in the application phase of the model. Now you can obviously put in any code here, any Python package is supported. So in this case, actually the developer of this code is also making sure that the categorical data values are hot encoded. And this model automatically takes care of categorical and non-categorical data points. Once we are ready, I'm kind of returning a dictionary here. So that includes the whole pipeline, that includes the encoding and the model. So on the application phase, it can apply those series of steps and give you the prediction and the probabilities. So essentially this now allows the Python experts to encapsulate their expertise, their good practices in Python code that anybody else can use. Now let's talk about the parameters. Obviously this is the code. How do we create the parameters that are appearing in the parameter panel? Pretty straightforward. That's provided over here in a simple JSON format. So this is a dictionary of all the parameters and they map 1:1. For example, the boosting type here is a categorical variable, so it appears as a drop down. The description gives the help menu. These are the default values. this is the default value, these are the possible values, and whether it's an optional parameter or not. So by defining this, you're able to create the parameters that appear here on the left. And then obviously you can throw in other things like, do you want other people to be able to change your code? If not, just change it to false. Do you want to handle special values, or what kind of different types of data point columns it can handle? Those are nothing but special values in the capabilities section. Once you do this, you're pretty much able to generate a Python operator. For immediate sharing, you can save it as a Python operator. So go ahead and drop it in the folder. Let's say lightgbm2, and it essentially appears like a PyOp operator that you can drag it around and use it in the workflow. Now, once you're ready to share with the broader community, or you want to put it on the AI Hub, you can simply right click and say create an extension that allows you to wrap up these operators like any other RapidMiner extension as a jar. And the users can then simply drag and drop like any other operator, where essentially what I was showing at the initial part of this recording. So this is how we now enable you to create Python-based operators that are compatible with the RapidMiner framework, allowing the Python experts to put their code, put their expertise in a drag and drop operator that the rest of the community can use. So let's talk about what else the Python enhancement on the RapidMiner AI Hub provides. So one of the immediate things I would want to show here is this is a code example of me connecting to some database. So I'm pulling some configuration data, getting some passwords, then eventually running some SQL, getting some data out. Then I'm creating the parameters and then building a model and applying the model. Now for Python expert, this is very natural and you can understand exactly what's going on. But as a data scientist, I want us to focus on the experimentation on the data science pieces. But a lot of times you will have to do things like, hey, ensure data security. So now you have to deal with how to store the passwords and how to encrypt it and so on, right? And also you have to connect to the SQL side of the house, but then you have to make sure that you take care of better practices like closing the connections, batch sizes, and so on, right? So this can become unnecessary time spent on things that really are not your focus. You're a data scientist, so you need to be able to get to your data science pieces quickly. With RapidMiner's AI Hub and the Jupyter Hub that comes along with that, we want to help you with speeding up the parts of the process that are not as much data science. For example, rather than creating a place for you to store username, passwords, and the drive or something like that, you can now start leveraging RapidMiner's connections. Connections are a way to store credentials and other details about connecting to different data sources or targets. And in this case, I'm connecting to a RapidMiner AI Hub, pulling a connection called a sample dev, and then I'm able to essentially get the username, password, and so on, and actually connect. So rather than having to worry about where to store, how to encrypt, I can simply rely on the RapidMiner AI Hub's capability to store your credentials and the connection details securely. Right? Now, the second part of this is obviously we still can use the SQL query to get the data and so on, but we want to make that part of the journey also easy. So essentially, rather than just saving the connections, we could actually create a RapidMiner workflow, and that's stored in this process called as get training data. From the AI Hub, I can now simply run a process. This will execute the workflow on whichever queue you select. You can pass parameters to it and so on, and it will bring you the training data. In this case, I'm getting the test data, and then I can focus on my machine learning pieces. That is where I write my code. So essentially now you're leveraging RapidMiner for the things it provides, like security of your connections, for the ability to connect to different data sources and mash up and so on, and then essentially deliver clear, clean data set that you can then write on that you can use in your Python code to start building great predictive models. This obviously works both ways, so you can run a process to get the data out, but you can also push the data and so on. Now, all of these notebooks and so on are also actually saved on the RapidMiner AI Hub, which provides a version control repository. So as you're making changes to the code and so on, we are tracking those changes, and then you have a Git-based backend that the AI Hub provides that manages version control for your team. The other common thing that a Python engineer would struggle with is the environment management. You may choose to use specific versions of packages. There are dependencies and so on. So how do we handle that? So with RapidMiner's AI Hub now, you have the ability to define Python environments. So in this case, I have about 6 of them. And to define an environment is pretty simple. You basically have a YML file that tells you which channels to get the packages from, the dependencies, and so on. And to create a new environment, you can simply upload a new YML file, and RapidMiner is going to create the environments for you to leverage. These environments are then available for the Python framework, execute Python, or the Jupyter Hubs notebooks that you just saw, so that you can now be assured that the packages and the dependencies are handled for you before you start running those Python codes. So hopefully with this new features, you'll notice how we want to bring the Python developers closer to the non-Python developers. Everybody works in a common environment. That is a RapidMiner AI Hub, and simple visual drag and drop workflows enables you to upskill your team, still leveraging the high quality packages that are available in the Python environment. If you have any questions, feel free to reach out. Thank you.